A very good afternoon to all. Today we'll see the lecture series as we discussed earlier about non-destructive testing. Okay. So in the previous lecture, we have seen that there are 6 common methods that are available, and these 6 common methods will follow a basic technique, that is the detection of defects is either by light or waves. Okay. Or sound waves, light waves, or images. Let us explore one by one. Ultrasonic testing is a testing which uses ultrasonic waves to detect defects. So you all well know that ultrasound is being used to detect the baby inside a mother's womb. The same technique is being used to detect the defect used in metals. Okay. So revealing the hidden defects without destroying the component is the main criteria that is being observed in ultrasonic testing. Revealing the hidden defects, which is by using high frequency sound waves that penetrates into the component. For example, we take turbine blades to reveal the microscopic cracks and internal discontinuities invisible to the naked eye. So turbine blades are subjected to high velocity of wind, temperatures, pressures, and everything. So every time the aircraft takes fly high in the atmosphere where the temperature is raised due to the high speed and the temperature in the atmosphere, these material of the blades will tend to fatigue. Okay. So this high frequency sound. So what is the frequency of ultrasonic waves? So it ranges from 0.1 to 15 megahertz, right? And even if it goes to 50 megahertz based on the requirement. Okay. So higher frequencies are used for application requiring greater detail, right? Higher frequencies can detect exactly the greater detail or the testing of very thin materials. Okay. And lower frequencies can be used for treating thicker materials. And when greater penetration is needed, as the higher frequencies attenuate more quickly in dense materials. So that is the purpose of using higher frequency. And why this frequency matters. So penetration depth, resolution, and detail material properties. So in summary, if we take this frequency of ultrasonic waves is not fixed. That is what we have to understand. It is chosen based on the specific inspection goal, and a lower frequency might be used for thick steel, while higher frequency is better for detailed inspection of thin plastics, as we see. So aerospace safety assurance and critical for ensuring the structural integrity and performance reliability of aircraft engines operating at under extreme conditions. So what is extreme conditions? Normal temperature and pressure. Okay. Normal temperature and pressure is normal conditions. Beyond this normal conditions, we have something called extreme conditions. Okay. So the other emerging techniques are thermal infrared rays, which uses heat flow patterns. And we have something called as acoustic emission testing that uses sound waves that travels through the component and gives back the signal. And we have guided wave testing and ground penetrating radar. So the real world impact case studies in this are aerospace safety, oil and gas protection, infrastructure longevity. These are all the real world impact of this NDT. Everywhere the NDT engineers are being hired or in demand because of this particular application. Okay. So coming to the data, that is annual industry losses is up to 1.2 trillion, and 70% of the failure reduction can be done, and 80% preventable incidents can be ensured through this NDT inspection techniques. The human element is very important. Skilled technicians and certification is important for this NDT inspection. Thank you all. And this NDT is an invisible guardian. Okay. Thank you for patient listening. We'll meet you in the next lecture series. Thank you all.